You're rushing to the station to get your train, the one that gets you to your night out or home from a long day in the office. You make it just in time, or so you thought, but you're faced with a train notice board that just says delayed next to all the trains. The voice over the tannoy declares they are sorry that your train is delayed and that it's due to a track fault. But what are these track faults and why do they cause trains to be delayed? Faults with the track can lead to one of two initial responses: blocking the line and stopping all trains, or imposing a caution and slowing trains down. The nature of the issue with the track will determine what that initial response is. Sometimes the line can be blocked, then once the issue is further understood, trains can still move over the area but at slower speeds. The first thought is always keeping trains and the people on board them safe. The problems with the track that can require the line to be blocked or trains to be cautioned are diverse and varied. In this video, we'll explore some of the most common problems. This way, the next time you hear track fault as the reason for your train being delayed, you'll have a better understanding of what the potential issue is. Let's dive in. Let's start right at the extreme. A broken rail is right up there in terms of severity and danger. It requires the line to be blocked as soon as they are found. Rails can break for a number of reasons. The root causes fall into two main groups: rail defects and the weather. Rail defects. Internal or external defects in the rail can weaken it enough to cause the rail to break. An internal defect is likely to be a taché unveil. The name comes from the French for oval spot, which describes their appearance. These taché unveils, or TOs, are inherent within the rail from excess levels of hydrogen in the metal. They are manufacturing defects that grow as the rail is in the track and subjected to the load of trains. Externally, the rail defect could be a squat, which is a localized depression in the rail and a dark spot. They look similar to bruising on an apple if you cut through the middle of it. They are an issue because of the micro cracks that then propagate or grow and lead to a rail break. It could also be corrosion that has degraded the rail material, leading to a weakness at that location. This most often occurs at the foot of a rail. External defects are caused by something not being quite right with the track overall. In the case of corrosion, it could be a wet environment such as a tunnel, or the presence of contaminants such as road salt and level crossing. With squats, these could be caused by track geometry faults such as voiding that can lead to an increase in the point load on the rail at that location. Now let's look at the weather. There is one time of the year that the weather can lead to rail breaks, and that is the first cold snap, particularly if the weather turns cold suddenly. But why? When continuously welded rail is installed, it is stretched to put it in tension. This helps prevent track buckles in the hot weather. More about them later. But when the weather turns cold, and the rails with it, the metal contracts, further increasing the level of tension. When the weather turns cold suddenly, the rails suddenly contract, rapidly increasing these forces. Where there is already an underlying issue, such as a rail defect, this sudden increase in tensile force can be enough to cause a rail to break. Another place rail breaks occur is around joints. Two areas are vulnerable here. First are the plates used to form the joint. With these plates being subjected to large and repetitive load, the metal fatigues, leading to cracks, and then the plate finally breaking. In these cases, the plates can be replaced, normally fairly quickly. The other area is the hole drilled for the bolts that secure the plates. Cracking, again from the loads exerted on the joints and the bolts, can start from the edge of the hole and work its way towards the rail surfaces. This is known as fatigue or star cracking. This can lead to chunks of the rail end becoming detached, which pose a very high derailment risk, as happened at Hatfield. Check out the video in the top right hand corner. So the rail is broken, now what? How maintenance teams approach a broken rail depends on the characteristics of the brake. These include the gap between the sides of the brake, so how far the gap is opened up, the distance along the rail between the bottom and the top of the brake, so the squareness, and the overall track condition around the brake. For example, if the track is voiding or bouncing. If certain criteria are met, such as a relatively straight brake that hasn't opened up very much, with the track around it in a condition that offers good support, clamps can be applied. This keeps the ends of the rail at the brake aligned. Trains can now pass over the brake at a slow speed, allowing trains stuck outside of stations to offload passengers or some level of train service to resume. The rail can then be changed after the train service has finished for the day, minimising disruption. If the brake is bad enough, then the only option is to replace the rail right away. This is relatively straightforward in plain line, provided enough people, tools and a suitable rail are available. But when it comes to switches and crossings, not so much. Switches and crossings are specially made or cast, so unless a spare is available on site, replacement can take time. In this case, one option is to do what is known as plain lining. This involves removing part of the switch and crossing layout and replacing them with plain rails. This means that only one route for the train is now available, but trains can get moving. This does, however, involve a large amount of work to achieve this. Switches and crossings are both subjected to regular and detailed inspection, as, due to their nature, they are considered an area of high derailment risk. At times, these inspections, particularly those of switches, will highlight issues that can cause the inspector to be required to take actions. The one that is most likely to impact the running of the train service is a ban to facing movements. This is imposed due to the profile of the switchblade, increasing the likelihood of a derailment. A facing move is one where the train travels over the switch, starting at the toes. As you can imagine, if a set of switches that have been banned are at a major junction and a facing move is frequent, this can cause a host of issues for the signalling and operations staff in running the railway. For more on derailment risks at switches, check out the video shown in the top right-hand corner now, or in the link below. Rectification can include welding and grinding works to the switch, or, in some cases, a full replacement. Neither of these are particularly quick. Perhaps a more common cause of delays that track maintainers have to deal with is what is known in the UK as a rough ride. This is a report from a train driver that they have felt or seen an issue with the track while travelling across it. This could be a bang, a sudden lurch of the train, or a dip in the track. Trains will immediately be cautioned, with the following trains asked to examine the line closely and feed back to the signaller. This gets as much information as possible back to the maintenance teams, mostly around the exact location of the issue. Once the maintenance teams get to site, the track can be fully inspected. The issues could be dips due to wet beds or voiding that cause the track to move when a train passes over it. Sometimes the issues can be major, such as a broken rail or a track buckle. The inspection may uncover the underlying cause to be something significant, like a failing embankment, or maybe it's nothing that can be found, known as a no fault found. If they're able to, teams can address the issues with manual repair works to the track, after which the line can be handed back at full line speed. However, if there is a significant issue, such as an embankment slip that has led to the track issue, then a speed restriction may have to be imposed for the safety of trains. Let's look at speed restrictions. Imposing a speed restriction is one of the main mitigations for track issues that engineers have. It is different to a caution, as boards are erected to tell the drivers what speed they must travel at. In the UK, a common speed restrictions are 50, 30, 20 and even 5 miles per hour. It is also common to see two speeds, one for freight and one for passengers. This is due to the different characteristics of the different train types. Speeds are designed by competent people who look at the current line speed, the track layout, gradient, and the signalling system layout to ensure the boards are placed in the correct place. But why does reducing the speed mitigate risk? Trains travelling along the track exert forces on the track and the components that comprise it. The level of force is linked to the speed of the trains. If the train's speed is reduced, the force on the track also reduces, therefore reducing the risk. So what issues could cause a speed restriction to be imposed? A rail defect. In some instances, the standard requires that a speed is to be implemented to help prevent deterioration of a rail defect. The defect could be internal, external, or damage to a switch or crossing. The speed will need to be in place until the defect is removed. Issues with the earthworks, either cuttings or embankments, can lead to the speed being reduced in an effort to manage the forces being exerted on them. This may come about from inspections following a rough ride call. Periods of prolonged wet weather often see earthwork issues come to the fore. A very common reason that speed restrictions are imposed is what is known as condition of track. This is a very broad catch-all term for when the track is not in a condition for a train to pass over it at full line speed. This could be poor track geometry, condition of the components within the track, the presence of cyclic top, a large amount of wet beds leaving little track support, or repeated rough rides where the root cause cannot be addressed immediately or determined. Now lastly, we have buckles. While a track fault, this one firmly sits with its root cause in the weather. Rails are essentially long metal bars restrained by sleepers and other track components to stop them moving. As a temperature heats up, the rails expand, as all metal does. This might look like the same forces that cause the rails to snap in the cold I showed earlier, but it is different, I promise. The rail is restrained, so after a certain point it cannot expand longitudinally any further. Therefore, as the force builds up, as the rail material continues to try to expand but cannot, then the only way for it to go is out to the side. Once the thermal expansion force is big enough, the track moves. This is a buckle. I do have a more in-depth video, linked in the top right-hand corner and in the description on track buckles, so do check it out. This track movement can vary from a small misalignment that takes close inspection to huge movements. In all cases, they affect the train's ability to run safely, so need to be addressed. The track can be slewed back into place, but until the track bed has reconsolidated, a speed needs to be imposed to reduce the force on the track and avoid a repeat buckle. I hope this has given you a bit more of an idea of what's happened when you're stood there waiting for your train and you see track fault on the notice board next to delayed. I would also ask you to just try and remember that there are men and women who are at that moment working hard to try and get your train moving. They're likely under a lot of pressure. I hope you found this video useful. If you want to know more about railway engineering, a great place to start is with our range of ebooks that are available at the links in the description. If you want a little added extra, by signing up to our email list at the link below, you'll get our free Guide to CAN ebook straight into your email inbox. Drop any comments or queries below, hit that like button, and subscribe so you don't miss a single video. Thank you.